Hello, everybody. How's everyone doing? You having fun? Enjoying VMworld? I'm lucky I get to go to this is now my 7th VMworld overall, not including the fact that, every year there's 2, right? I'm very lucky to be here. I'm very lucky to do San Francisco and Barcelona, both beautiful, beautiful places in the world. It's fantastic to be here. And thank you, by the way, for joining my session. I'm going to try my best to make it educational, fun, entertaining. There'll be some singing, some dancing. I also know myself well enough to know that I constantly run over schedule, and I want to respect your schedule, and I want to respect the next presenter. So I'm going to get started, here a little bit early, and if people come in after the fact, that's totally cool by me. So first things first. Hello, my name's Chad Sakach. I work for EMC. My role in EMC is I'm the leader of all of the SEs, so all of our technical systems engineers around the globe. They're nerds like me. Nerds of the world fight and unite, right? I'm the chief nerd, right? And I am a part of EMC's executive staff, but I'm still a nerd, right? So just on a quick show of hands, how many of you here in the room are EMC customers? By the way, thank you very much, all of you, for investing your time and confidence in us as EMC. And how many people here are VMware customers? Of course, our federation model between EMC and VMware has been very successful. It's rooted in VMware being independent from EMC. And customers have choice on how they deploy and how they operate. But on behalf of my VMware brothers and sisters, thank you all for investing your time and confidence in VMware as well. So what we're going to be doing today is we're going to be talking around what we're doing around this software-defined data center evolution. And I hate to ask you something. How many of you are going to come to the next session that I'm doing, not right after this one, but STO5420? Great. Hopefully after this, more of you will come. The reason why is that there was too much content to fit into one, so I cheated. And I split it up across 2, right? There's lots of good content in each one. They do stand on their own. In this session, we're going to be talking about the data plane side of software-defined storage more than the control plane. The other session is more around the control plane of what's going on in storage. So I just want to set that up. Now, one thing I want to highlight, we've done something cool. We've got this program called EMC Elect. It's like the vExpert program idea, people in the community. If you basically use the hashtag EMC Elect or send a note to any of those folks that are there, they'll answer your questions on the fly. So you can ask me questions at the end of the session, but you can also ask it on Twitter in real time. The other thing that I'd say is that there's lots of great EMC stuff to see and do here at VMworld. Obviously, it's VMworld, it's not EMC World, but there's lots and lots of cool stuff. At the booth, there's we're supporting the broad hands-on labs, but also there's an EMC hands-on labs that's near the EMC booth that you can check out. Lots of prizes and fun things to see and do. Now, again, show of hands. How many people will come to this session? The one later on. I think it's at like 3 o'clock. If you find this one interesting, you'll find that other one interesting too, right? So what I needed to, in San Francisco, these were in the reverse order, right? And just because of scheduling here, they're this way around. It's very important to understand the ideas of control planes and data planes when we talk about software-defined networking and software-defined storage. Control plane is how you tell something to do something. It's how you tell storage, I want a file system, I want a vVol, I want a replica, I want it to do something. In networking, it's I want a layer 2 set of services. I want a subnet, a layer 3 network. I want a firewall. So how many of you saw the keynote that Carl and Kit did? They've got a good little bit there on stage, those two. A lot of people don't know this. Kit Colbert is actually an engineer, not a talented actor. He's way too good looking and too tall to be a good engineer. No, he's actually a great engineer. He was part of the original team that built like the early days of ESX, vMotion, all that sort of stuff. And now he's become this talented guy standing up on stage in front of 8,000 of his friends, right? But that was pretty cool. What they were describing, a lot of those functions were about automation. Control plane is all around automation. And where do you put the control plane? If this is the land of all of IT infrastructure, you know, you've got hypervisor variation, you've got different infrastructures as service stacks, you have different operating systems that run inside those images, and then ultimately you've got complex applications that you want to deploy via blueprints. And then underneath that, you've got an insane variation of stuff, right, that do data plane type stuff. Data plane network, data plane compute, data plane of storage. The place obviously that you'd put control and policy and automation is literally right at this layer, in the middle of infinite variation up here and infinite variation down here. And I would highly recommend coming to that other session because we're going to talk about what we're doing around control policy and control plane automation between VMware, EMC, and the industry as a whole. In this session, we're going to be talking more about the data planes. So in storage land, the data plane is the thing that actually persists the data. In other words, it's the thing that first and foremost actually says, I'm going to write something, and I'm going to store it, and I'm going to give it back to you when you ask for it correctly, right? And I'm going to do it even in failure behaviors, and I'm going to be able to do it within certain performance envelopes. And in some cases, data planes and storage also offer data services, snaps, replicas, active-active models, all that sort of jazz. Make sense? Now, I'm going to try my best. There's going to be, invariably, I'm going to use EMC examples through this. But how many of you are not EMC customers? How many here are HDS customers? NetApp customers? I'm going to try throughout, and by the way, you know, we could go on and on. There's a huge variation. I'm going to try my best to use examples that could be applied across the industry because these ideas fit into different architectural buckets. So the main thing to understand in the data plane of storage is that there's 5 mega disruptors that are disrupting the whole storage industry, everybody, right? The first one is basically low-cost compute and massive multi-core compute being available at very, very low price points. That changes how you can do storage models. It means you can do distributed storage models like vSAN. You couldn't do vSAN without massive multi-core, low cost, right? And low-cost networking, right? You couldn't do all-flash arrays without this stuff. You couldn't do very large-scale, high-performance traditional arrays without this technology, right? The second thing is virtualization in general. Virtualization is changing the workload, but it also enables us to do new things in new ways. The third one is flash. Flash is an enormous one. I'm going to spend a lot of time on what's going on in flash. By the way, you couldn't have a Nutanix or a SimpliVity or a vSAN or a Scale.io without flash. All modern arrays depend now on flash as either a cache or a buffer or in all flash arrays is the persistent store for everything, right? The other one is convergence, where basically we're seeing new architectural models emerge where storage and compute are munged together, not separate, they're blended, right, in different ways. And the last one are cloud and cloud consumption models, so deploying things rapidly at large scale. These things are all things that affect EMC, they affect everybody in the industry, they affect VMware, and they're also the core technologies that we can innovate around. Does that make sense? Now, let's talk about the first, what these architectures are doing fundamentally to the architectures of data planes of storage. First one, you can go through this and basically say, when you add these together, that combination at the top is generating next generation hybrid arrays, arrays that serve many, many purposes, all moderately well, right? That's the definition of those hybrids, kind of do everything sort of well, right? Which may sound like I'm being negative on them, I'm not. That's actually a huge market of customers that need one thing that kind of does it all, a Swiss Army knife. The second combination are generating these new generation of all-flash arrays. The next combination is creating something called seas of storage. And I'll explain what each one of these mean, right? The next combination, of flash plus low-cost compute and network plus virtualization is enabling new models like vSAN, like Scale.io, like Nutanix, like SimpliVity, right? Where it's blended together in funky ways. And then convergence and cloud are enabling new models of data protection. And frankly, most important over anything is large degrees of automation. So I'm going to tackle each one of these 6 things, and I'm going to do my damnedest to do it on time, which is going to be tricky, So hang on to your hats, right? So another thing that I'm going to spend a little more time on in STO5420 is this topic. Every storage vendor on the planet, including EMC, all claim that their architectures are radically different than each other. And it's uniquely differentiated and better. And there are huge differences between all storage vendors. There's no question about that, and all storage architectures. But I'm an engineer and a computer science double major, so I'm a nerd. I've got the creds to prove it. When I studied comp sci and electrical engineering, and we were looking at file systems and storage stacks and how do you build them, it was true then what is true now. There are only 3 types of storage architectures in the world. Period. They fall into these 3 categories. Category 1 are basically clustered architectures, scale-up architectures, right? And by the way, you've got like EMC, NetApp, IBM have got stuff in this space, but you also have Pures in this category, so Tintri, Nexenta. So it doesn't, you know, some people say old guys, new guys. Doesn't matter whether you're a startup or a new player, you can look at a storage array and go, it is a one of these. It's usually characterized by brains in pairs, connected with some sort of very low latency interconnect, InfiniBand, PCIe, direct connectivity, that sort of thing, and disks behind it. Then you've got this second category, scale-out architectures. Now there's wide variation in these scale-out architectures, ranging from ones that are designed for huge tera to petabyte level NAS, but not so good at transactional workloads, through to all-flash variants that are built like this, through to arrays that look like this, which have tightly coupled brains. Why are they tightly coupled? Because literally it's a single memory architecture. In this one, it's loosely coupled. Here, they're tightly coupled. Here, every brain literally can read and write to the memory of every other brain. Why the hell would you do that? And what's an example of that? Can anyone guess? Throw out an example of that? Symmetrics is an example. What about a non-EMC example? 3 pars like this. What's another one? What's that? HDS, yes. USP, VSP would be an architecture like. Why the hell, you know what? So again, you see my point here. These all lump into these categories. Why are they designed that way? They're designed that way such that every I/O is symmetrical. In other words, you can read and write from a cache which is shared by all of the nodes. Why are they designed that way? They're designed that way so that you can withstand failures and still have linear performance envelopes. Make sense? Again, is it the right design for everything? No. Right? Each one of these has a sweet spot, right? And then this last architecture over here has got this engineering non-POSIX compliant file systems and object stores. What the hell is that? Right? It's HDFS, is a non-POSIX compliant file system. It's an object store. S3 from Amazon is one of these. Swift in OpenStack is one of these. Ceph is one of these. And EMC Atmos and Viper's data services are one of these, right? Does anyone ever use one of those things here in the room? You use it every single day. When you post a TwitPic, when you download something from iTunes, you are using a one of these. In fact, there's way more of this in the world than there is of all of this, even though these models are much more well known within enterprises. Okay, you with me so far? Everyone kind of going, I get it, Chad, what Chad's saying, right? Here's the next mind blower. Whether the storage stack is running on a host or whether it is an array, these architectures are the same from a storage stack, right? Meaning if it's just pure software or whether it's software bundled with an array, architecturally they're the same. Now, whether or not they're economically the same or operationally the same, that's a big variation. But architecturally, from an engineering standpoint, it doesn't matter how they're constructed or packaged. Does that make sense to everybody? Again, everyone with me so far? Check. Okay. This one tends to win. This architecture tends to win when the category is best Swiss Army knife. Why? Because this has the lowest code path complexity. It can basically deliver an IOP in the most direct fashion, a gigabyte in the lowest cost fashion because there's low ratio of brains to disks, right? These ones tend to have a higher cost per IOP or per gig, and they all have different data services, but they are simpler and easier to manage at larger scales, or in some cases for reliability, availability, and serviceability models, right? By the way, vSAN fits into this model, just architecturally, just as an example, and the VMware VSA fits into this model. See what I did? Notice, it doesn't matter software, hardware, architecturally, how do these things work? Make sense? And this one can't deliver a transactional I/O in its life, right? So it sucks for traditional applications that depend on low latency and on hardware resiliency. But if you can build software resiliency into your application, these things can be awesome because they can do magic things like geo-federation and lazy consistency around the world and stuff like that that are very strange and alien, right? So by the way, this is why when somebody says one storage architecture is the right way, they're high, right? They are smoking something. The only way that one storage architecture can serve all your needs is if you constrain your workloads to be the, to fit into the bucket that serves these best. That said, these architectures over here have the widest workload envelopes, right? So I'm going to talk about them in a little bit of detail. Let's talk about the first disruptor, flash. Flash, everyone goes like, oh, what's the big deal? If I said to you, I could sell you 10 petabyte per second Ethernet for the same price as gigabit Ethernet, would you be excited? You sure would, right? That's the sort of quantum leap that flash does to all storage models. And the price and performance, who here uses an SSD in their laptop? Would anybody give it up? No, right? Why? It's unbelievably faster, better, cheap, and it's actually cheaper, believe it or not. It's cheaper when you measure it in dollar per I/O, right? Where is it not cheaper? When you measure it in dollar per gig. Does that make sense to everyone, right? So this is changing architectural models in each one of these. New converged appliances, like I said, are dependent on it. Things like hybrid arrays and all-flash arrays. So I'm going to talk a little bit about what we're doing in hybrid land, right? So hybrids have got to be re-architected to switch from a model of flash being like a little bit of the mix to being a huge portion of the mix, right? Almost 100% of the arrays that we ship now to our customers have some degree of flash in them. Do we have VNX customers here in the room? How's it going? Good, great. Are you using fast cache? What's been the experience that you've seen? And what's the workload? SQL? Anyone else? How's it going? Yeah? That's great. So the point, guys, and again, I don't want to make it an EMC commercial. Other array vendors use the same architectural idea of saying, I'm going to use flash as a caching layer, right? As an absorber of IOs, right? Again, we would argue that we think we do it better than anyone else, but this isn't the place or the time to, like rah, 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 right? The other way to use it is as a storage tier, right, where it actually persists the data. So let me explain this in a little bit. And remember, the category we're talking about are hybrids, Swiss Army knives, right? Things that do it all well. And again, I know that as nerds and geeks, and frankly as humans, we always want to go, one way is the right way. Scale up sucks, scale out, way to go, all flash, hybrid. No, it's not that simple, right? We're architects. You need to understand choices, right? In this example, the Swiss Army knife needs to cover use cases where some customers are like, I want 6 petabytes of storage in a single floor tile. And I want it dense, super dense, and I don't care about IOPS. I'm fine with 134,000 IOPS, but I want 6 petabytes of capacity. In that case, it's all magnetic media, right? Tiny amount maybe for some fast cache, right? Most customers use a little bit of both. They use some as a cache, some as a tier, and they blend it, and they use some sort of auto-tiering to blend and move it around. And we have other customers who say, you know what, I don't care about capacity at all I want is 1 million IOPS. 1 million IOPS, right? But I want data services, I want it to do NAS and block, I still want it to do many things, but with a performance-centric envelope. Make sense? Now again, by definition, if you do many things well, you don't do any one of them the best. You're a decathlete. You know, you're not Usain Bolt, right? Like Usain Bolt probably couldn't high jump to save his life. But man, he can run the 100 meters like that. So you see the analogy. This is the decathlete category. So basically what occurred to us a couple of years back was our core design was starting to really show its age. And the primary thing that was driving it was the original Intel architecture didn't have a lot of CPU cores. It scaled up its performance by scaling up the frequencies of cores. And it didn't have a lot of memory bandwidth. The new architectures, so think of basically starting with Sandy Bridge, and then Ivy Bridge, and Haswell, and the subsequent processor architectures, lots of cores, lower performance per core, but lots and lots of memory bandwidth between cores. Make sense? The other thing that's going on is huge amounts of flash, not a little bit, but a lot. So we needed to take all of the code, and this is a huge re-engineering of the code, to take out Flare, which has been inside VNXs and is the heart of a VNX, and Clarion before it, right? We needed to gut it, right? You know, there are times where you gotta, and we actually debated even just completely saying it's dead and killed, but of course there's 300,000 happy VNX and NS and Clarion customers out there, so and they like it, right? So we're like, oh, you gotta be careful about how you do this stuff. But the long and short of it is that we replaced it completely with a new code base that's called MCX, which stands for multi-core. Now, when we say multi-core, everyone goes, well, weren't you always multi-core? And the answer was, yes, we were always multi-core, but there's a big difference. And here's the net. Our previous generation VNXs had an envelope like this. So who here has a previous generation VNX? Are you happy? So it's not like that was bad, right? The new VNX has got a performance envelope that goes way out to the side like that. Now, the name of the game in the hybrid is not super uber performance, but it is to support all sorts of crazy mixed workloads. The difference in the multi-core is that we used to assign a core to a task. And by the way, this is actually how most storage arrays still work, including VMAXs. Next generation VMAX is going to be re-architected in a similar way, right? Where basically cores would support a process or a function. So yes, we could use different cores, but it would mean that if one core was lightly utilized or one process was very heavy, it wouldn't get any extra leverage from going from one platform to the next. Does that make sense? In the new model, basically functions are completely like hypervisor time sliced, you know, across all of the cores in the system, right? So what that means is that you get much more linear scaling and much smoother performance models across the family, right? Does that make sense? And again, every storage vendor has to do something like this because it's the only way that you can leverage the massive multi-core and the huge amounts of flash that we're now seeing in the configs, right? This is what a small one looks like. Again, people are always, you know, interested in hardware bits and pieces, and you could go and see it and talk more at the booth. You know, basically you can get like about 200,000 IOPS in a 3U footprint, right? But the point here isn't mega IOPS, it's about data services. So block, NAS, dedupe, thin, this, that, the other thing, lots of workloads. Serving VMware, but also some SQL Server, some NAS, you know, again, Swiss Army knife. Make sense? Again, like as an example, vSAN, awesome, love it. I can't wait for the, you know, I'm using it in beta, I can't wait for the GA. I use Scale.io, I use all sorts of stuff. I have a crazy home lab. By the way, who here reads Virtual Geek? Thank you very much, by the way. I appreciate that. That's my blog, if you don't, check it out. The dense platform, rich capability. The bigger brother, which is called a Prometheus, you know, that's its engineering code name, it's a monster, right? Now, of course, the total amount of performance and IOPS is a function of the disks that attach to this. But you'll also notice like tons and tons of I/O ports. So we switched to PCIe Gen 3, full-blown connectivity that is dynamic and hot swappable, all sorts of cool giblets, right? And the net, more VMs can happily be deployed on the same class platform. The biggest and baddest of them is a VNX 8000. And it's amazing, I can't disclose the name of this customer. A customer that is a broad leader in the cloud business, and I'm not talking about VCHS here, bought 16 of these. So again, it's interesting. Like people kind of go one architecture, and every customer needs a little bit of everything. Make sense? So lots of great customer feedback. Do we have any customers, by the way, who have got a new VNX? Great, thank you. Very much appreciated. At the bottom there, we've got this one here is Citigroup. Who uses VNXs as the predominant block and NAS platform that supports their core VMware environment, but also a huge NAS requirement. So they're using SMB 3.0. But it's not all about block. There were huge changes in the NAS stack as well. So who here uses VMware on NFS? Oh, it should be more of you. VMware on NFS is great. So is VMFS. It's not one versus the other, right? But we made huge improvements to the transactional NAS stack behavior. Lower latency, more IOPS through the same stack. And the other thing that we did is we added the ability to have virtualized NAS functions. So you can move them non-disruptively. You can literally vMotion your NAS environment non-disruptively from one VNX to another, or from within one brain to another. That's a really powerful capability, right? And on the NAS side, a great example here, this one here is LSI. Huge user of VNXs for their EDA, basically designing and building, next generation bits and parts. Make sense? Okay. Now, beyond that, there's lots of goodies that are in the new code. So since this is a VMware session and we have VNX customers in the room, I wanted to make this clear to everybody. Dramatic improvements in Xcopy performance. Xcopy on the previous generation was not implemented as well as I think we could have made it, right? Now the good news is that for those of you that have previous generation VNXs, this is going to be backported. So this will arrive in a maintenance release for people who are using previous generation VNXs. Second thing is thin provision unmap, or TP reclaim, is fully back now in vSphere 5.5. And this is fully supported and works well. There's also a block dedupe code. And just because I'm like, oh man, I'm going to completely run out of time, I'm going to quickly show that to you. There's a ton of stuff here as well. Who here uses vCenter operations? Oh, it should be more of you. VCOps is awesome, right? There's deep VCOps integration with VNXs and VMAX too. So if you're a customer, and by the way, I'll give you a hint. EMC OEMs vCenter operations. It's sold to our customers as something called EMC storage analytics, right? If you don't have a VCOps license, talk to your sales teams and say, I want EMC storage analytics. Because basically what it is it's part of VCOps that you can get very quickly, and it only costs like $2,000, right? Now, what you'll see is you're going to fall in love with VCOps, and then you're going to want the full-blown thing because it is that awesome. But it's a great way to get started with vCenter operations. Does that make sense? So seriously, like, it's a no-brainer, right? I'm not in sales. I'm not saying, but I'd highly recommend it. So this is how the dedupe function works. So there's a post-process dedupe now. This is a feature which I think, honestly, it was a gap. And there were other folks in the industry who were doing it and did it earlier. Which is great. Sometimes in our industry, somebody does it first, somebody does it second. This is a place where I think our customers were really asking us for it. So I'm glad that we're doing it now. It's very simple to go in and, forgive the slightly garbled graphics, but I'll kind of explain what's occurring here. We've got a production system that's got a certain amount of capacity. You can turn on or off dedupe on a pool basis and then enable it on a device-by-device basis. Right? It can run on a scheduled basis as a post-process, or which runs automatically, and it can also be done on demand. And when you go through, the example that we typically see is heavily dependent on the data set, but in the VMware use case, where there's a lot of commonality between images, it's not uncommon to basically see a before and after, which is pretty dramatic, right? So again, what I'd highly encourage customers that are using VNXs and next-gen VNXs to check out this block dedupe capability, which is included, by the way, on the platform. And basically, the percent full in this example went from like 90% full to 3% full. Does that make sense? All right, check, good, okay. So, next, moving off of hybrids. And again, hybrids, I don't want to just make it sound like EMC. There's other examples. Nimble is a hybrid. NetApp, FAS platforms are a hybrid, right? Serve broad sets of use cases. But then there's this new generation of all-flash arrays. Anyone here using an all-flash array, of EMCs or anybody? Who are you using? So look, I couldn't have set that up. So by the way, his comment was he's tried Extreme IO, which happens to be ours, and Violin as well, right? And haven't decided yet. But both of them offered face melting performance envelopes, right? So face melting in a good way, not in a bad way. Right? So the point is that we're seeing new workloads which drive the performance envelope even higher. VDI is a common one, but so is very large-scale virtual server infrastructure, like the labs. Who here has gone and done the hands-on lab? The hands-on lab is supported underneath the covers by VNXs and by Extreme IO. Now, in years past, it was all VNXs. And I just told you about how awesome VNXs and hybrids are, right? They are. Great, fantastic. In years past, it took 18 cabinets worth of VNXs to support the workload of the hands-on labs at VMworld in last year. 18 cabinets, loaded to the gills with 10 gig and all sorts of SSDs and This year, there's one VNX on the side that supports just the NAS data and images that are backed up and stuff like that. But all of the images that you are using every day when you use the hands-on lab are all running off of an Extreme IO 4 sets of bricks that's about this high, right? That's the power of these all-flash arrays, right? Can they do everything? No, they are not Swiss Army knives, right? They do all sorts of things, focused on these use cases. And so what we're seeing is that the hybrids are moving up, not just from us, but from everybody, are moving up by using more and more flash, right? And some customers, LinkedIn, for example, uses an all-flash VMAX. Weird, right? But the reason that they use it is they need super performance, but they need rich reliability, availability, serviceability, and DR capability for their mission-critical databases that run how LinkedIn works, right? But trust me, they also use all-flash arrays all over the place, right? Because when you need RAS, those architectures are good. When you need face-melting performance and low latency, Extreme IO and the class of all-flash arrays, as well as new architectures that use all-flash on the host, tend to deliver the lowest latency. Does that make sense? Whether it's Fusion IO or our Extreme SF. Again, I'm trying to keep this I know that people don't like vendor sessions, so I'm trying to broaden it out, right? Make examples that are not just EMC examples. So the Extreme IO thing is fascinating, and one thing that's very cool as an executive is I get to see how our M&A process, our mergers and acquisition process works within EMC. What we do is we actually invest very early into lots of companies, and we do it in a way where we invest in the A round or the angel round, but then keep our hands off. Because many of those companies are trying to disrupt us. And we want them to go at it and fight with us in the market, and you as the customers choose. And if they're wildly successful, that's great. We get to see that's good, and maybe it goes public, and that's good, or maybe we acquire them. Does it make sense? It's a core part of how, by the way, it's not just EMC, how VMware works too, right? Look at the Destone example, right? Flash was invented by Toshiba in 1980. Man, think about what you were doing in the 1980s, wearing bad clothes and listening to awesomely bad music. But basically, I'm going to draw an analogy here. In 1858, this guy invented the combustion engine. It's like a core piece of, it was a French guy. And, you know, it's a great story, you know, that plays, est-ce qu'il y a des gens français ici? So, bonjour mes amis. As a Canadian, I love practicing my French. Like many things French, this guy invented something awesome and then maybe had some wine and cheese and never did anything with it. I'm totally joking. So people don't know that this is the guy who invented the internal combustion engine, and his original idea was to help mills, you know, be better mills, right? Eventually, these guys came along and said, you know what? We could actually make it to move people faster. And by the way, we saw the first flash arrays arrive in this market where they said, how do we use this new technology to power a new use case? Now, the guys over here, obviously Daimler's a pretty famous name, right? You know, and classic Germans, they took the idea and like ran with it, right? So what business were they in before they entered the business of using combustion engines? Look at the picture. Bicycles. So their first idea was, we'll make a bicycle with a combustion engine on it, right? And by the way, that's very analogous to how the first generation of flash players basically used flash. They use it as a very high performance thing in their traditional architectural model. If you look a few years later, you know, the Wright brothers invented the airplane. In other words, they discovered that, hey, we could use this engine to do something that is just totally different. We can fly, right? Now, the analogy here is that we're now seeing a third generation of all-flash startups up here that basically are looking at it going, how could we radically re-architect the whole storage stack to enable flash using different things in different use cases, right? So it really redefines what's possible. Here's an example. This case, I'm not allowed to say who the customer is, but trust me, we all know them. Huge retailer, basically was deploying VDI, and VDI is one of the primary use cases because you can do an inline dedupe, right? So it doesn't even matter whether it's thick, thin, persistent, non-persistent, how you do re-image redeployment, it just dedupes everything inline. And the inline dedupe is a scale-out model. You can scale out across nodes. They basically were really struggling with their large VDI deployment. This is, you know, a VDI deployment that goes up north of 10,000 clients. And they basically deployed 6 of these little X bricks, and now they've actually ordered another 12. And their comment was this one, which you gotta love, right? You guys are light years ahead of the competition. Now, it still hasn't GA'd, right? So we may be light years ahead of the competition architecturally, but the competition, of course, has shipping products, right? Now, but you can expect Extreme I/O to GA extremely shortly, very, very shortly. We acquired it. We gave the team in Israel time and space. You know, you just won the lottery. Congratulations. Take your time, finish building the product, harden it so it, you know, can have the EMC brand on it with all the support structure. But very interesting stuff. Here's a quick demonstration that I'm going to have to skip, but I'd encourage you to, just because I'm going to run out of time, I can already see it. This is an example where we basically did 2,500 login VSI users with Zen, right? Zen Desktop in this particular case with PVS. Very similar, of course, if we were using View 5.3, you know, in many architectural ways. Obviously, there's not an analog for the Horizon suite in you know, Citrix land, but basically, this is a huge workload, and if you've never done this before, creating VDI workloads for benchmarking is surprisingly hard. Login VSI is a pretty darn good tool to go off and do it. I'd recommend it. You do have to license it. It goes off and it actually causes all the desktops to actually not just boot and get created, but, you know, do stuff in them, right? So as you take a look, it's now starting to kick off the workload, and it's going to start to do stuff in all of the VMs. And just again, in the spirit of time, I'm going to just fast forward here a little bit. So, by the way, this is the array doing, you know, tens of thousands of IOPS, which doesn't even make a single X brick, you know, breathe heavily, right? But the CPU utilization across, this is on a UCS system where each one of them is a dense UCS blade, which are great servers for VDI use cases. And here you can see all the little images of people doing stuff. You can see that the amount of bandwidth that's being driven is huge. The capacity that's being used is relatively low because everything's being deduped in real time. And the level of performance is very, very high. This was gated fundamentally by the CPU and memory utilization on the servers, not on the XBrick, right? So if you want to see more on this, just go to Google and YouTube, Extreme.io, VDI benchmark, and you'll find the video and some dialogue. In the end, very, very good performance. You guys get that? It's very cool stuff. I'd encourage you to check it out. And again, if you're using the hands-on labs, you're already using Extreme.io, right? Now, let me jump ahead to the next thing. What the hell is this sea of storage thing? So everybody focuses on transactional storage and storage for VMs. I do too, because when I cut here, I bleed VMware. When I'm cut here, I bleed EMC, right? I love VMs as a huge workload, but you know what? It's not the only workload that exists. So again, people don't see this type of storage, but the world's biggest Hadoop clusters are measured in exabytes, right? The world's biggest object stores are measured in exabytes. There's one Web 2.0 company that basically bought 85 petabytes of EMC storage in a single go. And literally, this is a picture of the stuff shipping from the factory, right? Almost like, more than 20,000 spindles. What the hell is this thing? And who the hell is the customer, right? The answer is that the Web 2.0 and content providers. So if I named off Facebook, Netflix, iTunes, iCloud, make the whole list. I'm going to say that many of those customers use things like this, so that way I can avoid saying who it was, right? Because those folks tend to be relatively secretive about parts of their architectures, right? But this is basically, there's a sea of storage that exists out there that we don't even see in our enterprise world, right? But it's used for next generation applications. It's very, very cool stuff, and we need to build next generation models of these object stores, of these HDFS models. And by the way, if you're interested in it, dig into it. It's very cool stuff with lots of neat stuff going on. Now the question inevitably is, if there's all of this architectural variation, where do they fit? And there actually is a way to view the world, which is that basically there's a hot edge. There's a hot edge of IOs that are extremely hot, that are going to be more and more biased every day to be on the server, right? Using flash and magnetic media on server. Then there's going to be workloads which are a better fit for things that can do rich data services like scale out, inline dedupe, but also very, very hot. This next layer, if we call that the hot edge, is still relatively small to the mass of data which is used for hybrid purposes. Now remember, I've drawn the EMC example. It could be non-EMC in here. And remember, don't get hung up on whether it's hardware, software together, or whether it's software, bring your own hardware. Make sense? Right? These architectures that use blends of flash with lots of magnetic media are kind of the, think of it as the middle. And the cold core, meaning object stores at very large scale, archive, stuff that's sitting in cloud storage models, are basically how these things fit together. Does that make sense? And each one of them has their use cases. For most customers, by the way, if you have to use just one, right, because that's the best fit economically, the ones which are the Swiss Army knives typically are the right choice, just as a guiding principle, the category, right? Now, what about next generation convergence? So what do I mean by this? Convergence is an interesting idea. So who here considers themselves a nerd? Come on, be proud. Right? You can be smart and cool and social and still be a nerd. Right? Cool nerds. That's what an SE is. Right? At least we try to be. So this is a tricky concept for technical people because you have to momentarily take your brain outside of architecture. The value proposition of converged architecture are these 3 bullets. They want simple, the customer says, I don't want to doink around with server, network, and compute. I want to just accelerate my outcome. I want to hyper-standardize my deployment model and just go. Right? That's the reason that people like converged, number 1. Converged architectures can be built in different ways and will continue to change and evolve over time. All right? But their core value proposition is constant. And the last thing is that all converged architectures of storage, network, and compute break organizational silos. So in other words, their value is that you don't have a storage team and a networking team and a server team. You have a converged infrastructure team, a cloud ops team. Make sense? And that's its feature. Sometimes people struggle with that because they like silos. Generally, in the cloud era, silos are bad. Right? Every successful cloud deployment I've ever seen has a horizontal model, a cloud engineering, cloud ops team, not a server network storage team structure, right? So what's interesting is there's a furious debate in the blogosphere and amongst the community that says, is the right way to do converge something that looks like this, or is it something that looks like this, right? In other words, one says I've got storage, I've got some network, I have some blades, and I deploy them in blocks. A V block would be the VCE example, but there are other examples, right? This one over here says, no, what I do is I buy servers with disks in them, and I attach them to an Ethernet switch, and I use something to create a distributed software stack for storage. What are examples of these? Shout it out. Scale I/O would be one. What's another one? Nutanix. SimpliVity. They've got a cool car in their booth. Man, I'd love to have an R8 like that. I do not. I drive a Honda Odyssey. Like, it is a cool car. The girls love it. And by girls, I mean my 8-year-old and 10-year-old. It's got a TV in it, Daddy. And vSAN also fits into this architectural model, right? The reality of it is that they each have a sweet spot. This one, its unit of scaling is pretty big. It's hard to shrink a V block down to deploy 100 VMs. It's possible, but not really the sweet spot, right? Its sweet spot is I have hundreds of VMs, maybe thousands of VMs. Its sweet spot is that you can scale CPU, network, and storage independently, right? So if your workloads have varying sway of how much compute, how much storage, these ones, you're adding brains and disks always in some, combined ratio, right? The flip side is this is a model that can scale down, just down to, frankly, 2 or 3 hosts, right? And can be small and easy and can be deployed in the back of a Humvee. As an example. Does that make sense? But it also can scale up and scale up, right? Frankly, the industry is going to decide whether both architectures have their place, whether there's a trend to one or the other, and we can debate over beers and cocktails, which I happily would enjoy. So I'll see you at the party tonight. We'll talk about it more, right? My view, my personal view, is that both of these architectures actually have their own long-term legs. They have use cases where each one of them tends to be dominant, right? The main thing to think about as a customer is as you're evaluating these architectural models, say, what is the scaling model and what scaling model do I need, right? How well does it support my workloads? Not all workloads are the same, right? How does the CapEx model work? What is the OpEx model, right? And you can look at these two things as basically two different variations of the same core idea. Does that make sense? How much time do I have? I've got about 10 minutes left, right? Okay, good. So Scale I/O is a technology from EMC, which is really, really cool. And it's like think of it as an open variation of vSAN, right? So vSAN is awesome because it's tightly coupled to the VM kernel. It knows where VMs execute. And therefore, it can actually say DRS policy maps to copies of the underlying storage. In other words, I'll move VMs to where I know the copy of the data is local. Does that make sense? It's hyper integrated into vCenter. So simple and easy. You saw it this morning. Click enable. And by the way, go to vsanbeta.com and download it and start to play and hammer on it. It's pretty darn cool. So what is Scale I/O? Scale I/O is a version that's not bolted into the VM kernel. So it doesn't have the same degree of core integration with VMware, but the flip side is that you can use it at any scale and for broad sets of workloads, right? The way it works is it's software, currently Linux only, but Windows version is now in beta. And here you can see that there's 50 nodes participating in this cluster, right? It's software only, and it grabs the local DAS and SSDs and basically balances all of the data across the cluster. So like all of these models, it needs to do several things. It needs to basically have data integrity, data copy, but it also needs to be able to blam in a new node. So in this case, I didn't blam in one node, I blammed in 10 more. So notice it's now 60 nodes, and you can see basically it's rebalancing across the cluster. Does that make sense? Now the other thing that it needs to do is how do you deal with a failure? So by the way, this is a case where we went out and we shot one of the nodes in the cluster, right? And you can see that this one here is faulted, and you can basically see that there's a rebuild balance going on. So this is the faulted one, it's getting rebuilt. What I'd encourage everybody here to do, Google Virtual Geek Scale I/O beta. When you go there, you're going to see a link, click, go through, and you can download it. This is not in beta, it's actually GA. There's a 1.1 version, which is GA and actually being used by lots of customers around the world. There's a 1.2 version, and particularly if you're a customer that has Windows hosts that you'd like to install this on, please give it a shot. We want more Windows beta customers. The existing product runs on a Linux kernel only. Does that make sense? Okay, cool. Please check it out. Now, what's fascinating about this is increasingly we're seeing a separation of church and state. What I mean by that is today, things like VMAX, VNX, and Isilon are software, but they're bolted to the array itself, like the hardware. We have some models like Atmos, which is our object store. Some of those sea of storage examples are using Atmos. That is software only, and you can bring your own hardware. Scale I/O is just a software, bring your own hardware. That's its only model, right? But what's fascinating is that by the end of 2014, we will actually have VNXs, so VNXs which are software only. What would you use that for? If you like the data services of a VNX, you like its NAS capability, you like its dedupe, and you just want to run it on whatever you've got, right? Maybe on top of vSAN, right? VNAS. VNAS is a joint project which we've talked about enough publicly that I don't mind saying it. It's a project to basically say, how do we take the Isilon NAS stack and make it a core part of what VMware does? So VMware would come out of the box with vSAN to store VMs, but also NAS capabilities, to go out and share stuff. Does that make sense? Any Isilon customers in the room? How's it going? Just good, thank you. Anyone else? Good, thank you. By the way, we're also doing this with all of our data services. So these are products that don't actually store data, but do something with it, right? Data domain stores it. Avamar already exists like this. Avamar, as you guys know, is built into the VDP, VMware Data Protection capability, and all the new awesome stuff in VDP-A, VDP Advanced. You can actually now, any data domain customers? Just as an example, what you can now do with VDP-A from VMware is awesome. It actually supports DD Boost. So you can actually push your backups directly to the data domain target, and it's smoking fast performance for big VMs, right? There's a vRecover point already out where you can use any Recover Point customers. Recover Point customers use Recover Point physical appliances. You can now use a virtual Recover Point appliance. And there's a beta that allows you to actually replicate a single VM, which is really awesome, software only, right? Think of that as like a vSphere replication on steroids, right? And any vPlex customers? vPlex creates an active-active storage model. What are you using it for? And are you using it for like a stretch clustering use case?
Yeah, actually we have three installations.
Yeah. So 3 deployments across the Nordics. Basically, a common use case is to create stretched clusters, vSphere clusters that are in 2 places, and that gives you vMotion and mobility, but other reasons too. There is a vPlex coming. Beta in Q4, targeted Q1-ish GA date, right? I get myself in trouble sometimes. A lot of times, actually. So what's interesting here is in the data protection space, I want to give you an example of this Recover Point VE, and so you can see what this looks like. So again, forgive the garbled graphics here a little bit. But if you want to see a higher res version of this, again, you can go to YouTube, you can find it there. Just, look up Recover Point Virtual Geek, you'll get the blog post, it'll link you there. Recover Point basically here has 2 sites. One is in Las Vegas, one is in Barcelona. It's using virtual Recover Point appliances. This is the Recover Point UI. Again, forgive the garbled graphics, right? But what I really want to show you is that these things are now just VMs. Note, VM. This is the place where it gets really cool. This new capability, this button here, you can't read it, but it says Protect with Recover Point, right? So when you go and you click on that, and by the way, these 2 VMs that I'm protecting, one of them is on vSAN, and one of them is on just DAS, right? So in other words, it does not depend on the underlying storage array being one vendor or another, right? And when you go and say, protect via Recover Point, it takes you through a nice little vCenter wizard. Obviously what we have to do is rebuild this in the full-blown web client as opposed to the C# client. But basically, what this does is it gives you all of the capabilities of Recover Point, deduped replication, huge consistency groups, massive fan-in, fan-out ratios and all that stuff in a software-only way. Does that make sense? Very cool stuff. And again, if you go to beta requests at emc.com, you will get the bits to do this. Check it out. It's awesome. Last topic, remember there were 6 in the list of disruptive stuff, is extreme automation. Everyone is curious what's going on with vVols. vVols didn't make it into 5.5, but it is committed for the next version of vSphere. And one thing that is interesting is the core implementation to make this work is actually already in the core products that are out there. It's going to need a patch for the EMC storage arrays for sure, but in the current shipping versions of the arrays, there's the prototype vVol code so that we can actually co-develop with VMware, right? Because we need to be developing this stuff in real time. So in this example here, it says a VNXE. It's actually not a VNXE. It's actually a future VNX. Future code. I'll, talk to me afterwards. I'm starting to twitch, right? Well, I'll buy you a cocktail, say thank you for coming to my session. You buy me a cocktail. We'll do that a couple times, and eventually I'll tell you everything. The point here is that with vVols, you no longer create data stores, right? You create storage pools, and the storage pools are connected with the storage policy-based management layer of VMware and with something that EMC does called Viper. And what happens is as it goes through, it can actually tell the storage subsystem, what do I want? Out of this container, I want the bronze, silver, and gold. You know the example that they gave in today's demonstration? Today, when you want to use an external storage subsystem, storage DRS picks the data store, and the data store is fixed as gold, silver, or bronze. And therefore, that limits the ability to replicate or to make storage placement decisions. Right? It's not very optimal. What would be much more optimal is if literally every VM had its own container where the policy would be enforced at the VM level. And that's what vVols is all about. So again, if you want to check out this demonstration, you can see it in high res. Again, forgive the graphics on the screen. Just YouTube, vVols, VMworld, and you'll see it on my blog post. One thing I wanted to mention here, just for what it's worth, is who thought the demonstration that you saw from Carl and Kit was cool? Like, come on, that's really, I wish all our customers ran that way. At VMware and at EMC, we have a goal in our mind. The goal is to have like 10 to 20,000 well-run private clouds at our customers around the globe, where well-run means that they can do what you saw on stage. The technology is actually ready. but it's not as simple as you saw on stage, right? It's about how do you assemble, how do you integrate, which is mostly about partnership, trust, and services, right? How do you make VCAC work? How do you tie it into VCD? How does it work with vCenter? How do you automate workflows with VCO? How does that tie into the various pieces of your infrastructure? How do you deploy Puppet, Chef, and vFabric App Director, like you saw for the blueprints? Does that make sense? How do you actually, and every customer is a little bit different. So VMware and EMC together have got a series of services that we've developed around this stuff that I'd highly recommend. If you're on that journey and you like what you see and you want to go down that path, you can go solo and we'll partner with you and help you work. You can find lots of great information on the internet. That's awesome. But if you want someone at your side to help you through it, VMware and EMC have got services down each one of these things, right? This is basically focused on how do you get VCAC and vCenter Ops going. This one is how do you basically do the DevOps stuff using the vCloud suite, Cloud Foundry, and Puppet and PaaS. How do you get that IT business management stuff, that chargeback stuff that Carl kept harping on, you know, for pricing and price transparency, which is one of the parts of a well-run cloud. And this one down here is, hey, let us help you build your services catalog. So just for what it's worth, don't look at this purely as a technology discussion. Think about how do I get from point A to point B. Now, one last demo, and I know I'm running out of time here. This is really cool. So there's a project called Project Alta, and Project Alta says, how will NSX affect storage stacks? Everyone thinks about SDN primarily as a general purpose network thing. But the answer is it's going to affect storage networks too, right? Storage networks are another type of network. And so what Project Alta is about, which is really cool, is basically, this is a logging in obviously into the vSphere web client. I'm going to go in, I'm going to configure NSX in a virtual wire, right? But this virtual wire doesn't terminate on a VM. It actually does terminate on a VM. It terminates on a VMAX VM, right? So, but it's a prototype of how we're building the next generation VMAX, right? And one thing that's very interesting is the idea of being able to terminate a virtual wire, do native VXLAN and STT termination of the you know, core function of the what Nicira now, you know, NSX, the NVP controller does. And being able to terminate that means that you could actually create a logical storage network for a tenant, right? All the way down to the interface on the storage subsystem. What does it mean? It means that we have a distributed virtual switch running natively on the storage array. Does that make sense? Right? That complies with the APIs that the NVP controller uses to hit it. Does that make sense? You guys kind of visualizing that? Now, of course, this is not going to work over fiber channel. This is all about, you know, Ethernet attached storage models, right? But we're seeing that more and more. If you're not already looking at this, these, you know, don't feel like you have to stick with fiber channel because that's the only way that you can create a high availability storage fabric, right? If you're using it and you love it, great, you know, fantastic. But if you're, you know, looking at how to do these things net new, you know, Ethernet is really, really a strong way to build a storage network. You just have to pursue it with the same discipline that people do when they're building their fiber channel networks. Does that make sense? Same operational discipline too. In any case, what occurred here is basically you can see that I've got a VSA VMAX 10K. Doesn't exist in real life. I stole it from engineering, right? And basically what occurred here is we basically created an interface for a tenant, right? Very interesting idea. And basically what we did here is, you know, this was, by the way, Matt Cowger, a great global architect, a great V specialist, you know, who supports VMware as a customer. And if you don't subscribe to his blog, you got to check it out. In any case, so he logged in here and he's like, he forgot his password. But, you know, basically what he did is he did some performance tests of before and after of going through a virtual wire or a physical wire, an iSCSI termination. And basically, this wasn't about creating a benchmark like a monster performance result, but basically what we found is that the performance is basically a wash, right? So, which is good. Make sense? So, wrapping this up, I've got 5 things that I want you to take away from this session. Number 0, please come to STO5420. where we're going to talk about the other half of what's going on in storage land, which is software-defined storage control planes. SPBM from VMware, Viper from EMC, and other ideas. The other takeaway is our view as VMware and EMC is we have the same view of the software-defined data center as the goal. We pursue it together. Like many of the examples, you'll notice that I talked about VMware technology in EMC, EMC technology that's embedded in VMware, but we do it with an open federated model, which means you have choice. If you choose to not use EMC, I'm sorry about that, and we'd like to persuade you otherwise, but it's okay, right? If you choose, by the way, to not use VMware but use EMC, right, that's also okay, right? That's a very important model as we're going down this path of how do we try to construct this model. Customers expect us to be open and flexible and let them have choice. Those disruptors, Sandy Bridge, low-cost RAM, flash, virtualization, convergence, and cloud and SDDC are huge disruptors, and they're changing the way the whole industry works. I used many examples throughout this, EMC and non-EMC ones, right? You will see this show up in all sorts of different flavors, takeaway point number 3. And when someone says to you that only one of these things is the future, walk away slowly, right? The reality is it's going to be all of these things, right? And definitely play with Scale I/O, play with vSAN, right? You can expect more and more data services like protection, the recover point example that I gave, data backup with like VDP, to be software-only models. And if you want to play with that, again, beta request at emc.com is how you can get access. And then the other thing is that ultimately automation is everything. So automation of how you do all these things. And by the way, I'm going to be talking in the other session about how have we constructed the vCloud hybrid service, and how do we automate it? How do we use Puppet to, you know, remember Bill Fathers was on stage in day one, the keynote with Pat, and he said we're deploying a new VCHS data center in the UK. That thing is being stood up 10 times faster, not 10 times, almost 100 times faster than the first VCHS instances that we built in Las Vegas. Why? Because a crazy dude named Nick Weaver basically built this thing using Puppet and Razor and a thing that he built called Zombie that was basically built to basically stand up VCHS instances like that, cookie cutter, which is open source code now. So if you want to learn and play, it basically does metal as a service, right? Like the whole layer of the stack right up to the infrastructure, and then you deploy everything, including, by the way, all the VMware layers in the element as well. But then subsequently, you use VCAC for all of the provisioning and requests like you saw in the demo. So just take those things away. Enjoy the rest of the stuff around EMC. I'd encourage you, again, to come to the sessions, to come to the booth, play in the labs. Thank you for your time, and please fill out the survey. I want to hear your feedback, positive, negative. And again, thank you so much for being EMC and VMware customers. It's very much appreciated. Now, you don't have to clap. No, you really don't. Do you have questions that you want to shout out and ask? We have a few more minutes before they give us the one question. No? You can, one question.
Sorry, Chad, are we going to see any advancements in terms of the availability of...
Chad, are we going to see any new VSAs in terms of what EMC provide for us to play with? So
yes.
Currently we've got file.
So you can expect the vVNX, the vIsolon, the vData domain, the vPlex, the vRecover point, all to be generally available throughout 14.
Fantastic, thank you.
Yep. What's that? How many cocktails? One